stop calling it a gas giant. If you were to take a spacecraft and dive into Jupiter, you wouldn't float harmlessly through a cloud. You wouldn't find a rocky surface to land on, and you certainly wouldn't fly out the other side. Instead, you would hit something much stranger. You would splash into an ocean that has no bottom. Almost everyone gets this wrong. The textbooks told us that Jupiter is a massive ball of gas, but the reality is terrifyingly different. Jupiter is a liquid planet, and as if that wasn't alien enough, deep down in the dark, it becomes a planet made of liquid metal. Beneath those iconic swirling stripes lies one of the deepest mysteries in our solar system. The only way to understand it is to strip away the layers, look past the lies we were taught in school, and dive straight into the pressure cooker. But before we go down there, we have to understand why we got it so wrong in the first place. For decades, our relationship with Jupiter was superficial. We had photos, of course. In 1974, Pioneer 11 gave us our first close-up, and in 1979, Voyager 1 gave us our first moving images. They were beautiful, but they were deceptive. They showed us a dynamic, shifting atmosphere, and because we couldn't see the ground, we assumed there wasn't one. We assumed it was gas all the way down. It's easy to make assumptions when you're dealing with something this big. The scale of Jupiter is almost impossible to wrap your head around. It isn't just large, it is heavier than every other planet in our solar system combined. It takes up enough space to fit 1,000 Earths inside. If our planet were the size of a grape, Jupiter would be a basketball. With that kind of mass, the standard theory of planetary formation suggests that Jupiter grew by eating up everything around it. A core formed, gravity kicked in, and it sucked in all the gas in the neighborhood. This theory is neat, tidy, and logical. It implies that deep inside, there is a solid rock and metal ball, just like Earth, only buried under billions of tons of atmosphere. That is the story we all accepted. It makes sense, it's comforting, it's also completely wrong. The first crack in this theory didn't come from a textbook, it came from an explosion. In the mid-90s, the universe handed us a rare gift, a once-in-6,000-year event that changed everything. In July 1995, a comet named Shoemaker-Levy 9 was hurtling through the solar system at 216,000 kilometers per hour. It was on a collision course with Jupiter. The planet's massive gravity tore the comet into 24 pieces, turning it into a shotgun blast of ice and rock. Usually when things hit Jupiter, we miss it. But this time, we had eyes on the target. The Galileo spacecraft was arriving at the planet right as the impact happened. It watched as fragments of the comet slammed into the atmosphere. The largest piece unleashed the energy equivalent of 300 million atomic bombs. It was the biggest explosion ever caught on camera, but it wasn't the explosion that mattered. It was the debris. The impact punched a hole in the clouds and kicked up material from deep inside the planet, flinging it into space, where Galileo could taste it. It found water, a staggering amount of water. This didn't fit the gas ball model. This was something complex, something wet. It was weird enough that NASA launched a dedicated mission, the Juno probe, to scan the planet's interior, starting in 2016. What Juno found destroyed the old textbooks. So let's go there. Let's take the journey that your science teacher never could. Let's descend into the real Jupiter. We start at the cloud tops. Here, the temperature is brutally cold, below minus 100 degrees Celsius. You are surrounded by ammonia and water ice crystals. This sounds peaceful, but these crystals act as a natural antifreeze, creating an electrified environment that triggers lightning storms thousands of times more powerful than anything on Earth. You'll see hail, slushy balls of ammonia and water falling into the darkness, melting, evaporating, and rising again. It is a violent, churning cycle. Dominating this chaos is the Great Red Spot. From space, it looks like a flat storm, but from down here, you realize its true scale. It is a towering monster, 10 times taller than Mount Everest, and extending deeper than Earth's deepest oceans. It reaches so high, it touches the upper atmosphere, getting sunburned by UV rays, which turn its chemicals that deep, angry red. But this violent weather, this is just the skin. The average depth of these clouds is only about 50 kilometers. That is nothing compared to what lies beneath. As we descend past the clouds, the light fades. The temperature begins to spike, the pressure starts to crush you. This is where the concept of gas giant dies. On Earth, gravity pulls you down to the ground. On Jupiter, gravity pulls the atmosphere down on top of itself, squeezing the molecules tighter and tighter. You are entering a fog that gets thicker by the mile. It's like sinking into a deep mist that slowly becomes a slurry, and then without you ever hitting a surface, it becomes a fluid. At a depth of around 1,000 kilometers, the hydrogen gas is compressed so intensely that it stops being a gas. It becomes a liquid. This is the true face of Jupiter. It is an ocean of liquid hydrogen. It is the largest ocean in the solar system, spanning tens of thousands of kilometers deep. There is no boat that could float here and no submarine that could survive. On Earth, we can make liquid hydrogen, but we have to freeze it to near absolute zero. On Jupiter, the rules are inverted. The pressure is so immense that the hydrogen stays liquid even as the temperature climbs to thousands of degrees. It creates a pitch black, boiling sea that effectively has no bottom. But we have to go deeper. We have to go to the place where physics starts to break. We are now 20,000 kilometers down. The weight of the world above us is unimaginable. The pressure is millions of times greater than the surface of Earth. The temperature is hotter than the surface of the sun. Here, the hydrogen atoms are squeezed so tightly together that their electrons are forced to break free. The liquid stops acting like oil or water and starts acting like metal. This is metallic hydrogen. It looks like mercury inside a thermometer, a shimmering silver fluid moving in the dark. Because the electrons are free-flowing, this ocean conducts electricity. As the planet spins, this churning liquid metal generates the most powerful magnetic field in the planetary system. This is the engine of Jupiter. It isn't a cloud, it is a dynamo. This metallic ocean makes up the majority of the planet's interior. It goes down for another 40,000 kilometers. And finally, at the absolute center, we should find the solid core. The rock, the seed that started it all. But when we look at the data, the core isn't there. Well, it is, but it's not what it's supposed to be. We expected a hard, dense ball of iron and rock. Instead, the data shows a fuzzy core. There is no hard line where the liquid metal ends and the rock begins. The center of Jupiter is a dilute, messy soup. It spans half the planet's radius. A chaotic mixture of liquid metal and dissolved rock, all stirred together. This shouldn't be possible. In computer simulations, heavy rock settles to the center and forms a ball. The fact that Jupiter's core is sprayed all over the interior suggests a violent history. The leading theory is that Jupiter didn't grow up peacefully. Billions of years ago, when the solar system was young and chaotic, a massive protoplanet, something 10 times the size of Earth, may have crashed head-on into Jupiter. The energy of that impact would have been catastrophic. It wouldn't just leave a crater, it would have shattered the planet's internal structure, smashing the solid core and mixing it into the liquid mantle like a blender. It created a planetary wound that hasn't healed in 4 billion years. So when you look up at that bright point of light in the night sky, remember what you are really seeing. You aren't looking at a puff of gas. You are looking at a planetary grave. You are looking at a swirling liquid metal ocean that hides the wreckage of an ancient collision deep within its heart. We have learned so much, yet we still don't know exactly how this monster was born or why it hasn't settled down. Jupiter remains a giant spinning question mark, and that mystery is exactly why we keep watching. If you want to join us as we uncover more secrets of the cosmos, make sure to subscribe and turn on notifications so you never miss a discovery.